what was the first purpose-built educational computer? Now, a while ago I was in a museum and I saw a machine which I think, well, as far as I can tell, is probably the first purpose-built computer that was designed for schools. And the machine itself is quite a large machine, and it was never sold, so several were made but none were ever actually sold, so from that point of view it's a sort of hidden machine. But quite a few were made, sort of 10, something like that, maybe a few more, and they were trialled as well in schools, and at least one of those machines was operated for about a decade, about 10 years. Now, the machine itself is an IBM experimental schools computer, and it's quite a large machine, and it's quite familiar in a lot of ways because you've got a keyboard, which in this case is a touch keyboard, so there's no moving parts, which is probably more robust for schools. And it sort of looks like a sort of early home computer because instead of a monitor you actually use a domestic television set, and to store programs you use a cassette recorder. But the similarities sort of end at that point, because this project was started in about 1966, which is before any microprocessors, and so internally it's quite unfamiliar, at least compared to home computers that came after it, because internally it uses the IBM SLT technology that was in the IBM 360, so it doesn't use the normal TTL logic and so on. And something else that makes it fairly, well, not unique but unusual, is that it doesn't actually use hexadecimal. It uses BCD, so everything's in decimal, which is sort of easier for people who are learning computers for the first time because you don't have to get over that hexadecimal hurdle. And also, because it's so early, it actually had to use core store. So the machines had a ferrite core store, and all the memory and all the registers for the machine were in core store. So it was non-volatile. And when you get down to things like word size, because this machine was programmed essentially in machine code, there was no high-level language, although it's not a sort of machine code that you'd expect from the later microprocessors. It's a bit more complex than that. And it was programmed in machine code in BCD decimal, and it's got a register set, and the registers and the core store are actually 32 bits, so it's a 32-bit machine, although they are 32 BCD bits, so you've got digits in groups of 4, so you don't get the large integers, or not as large as you get with a 32-bit machine, but it is actually internally 32-bit, apart from a couple of double length registers which are 64-bit. So it's got quite a large word size. But what was interesting about it was when I saw it in the museum, there was actually a programming card there, and on that programming card was the instruction set. And with a bit of research I actually managed to find more details than just that instruction card, because there wasn't enough information there. And I managed to find a document which detailed in quite a lot of depth actually the instruction set, enough for me to make one of these, which is essentially the same machine but just re-implemented using a Raspberry Pi Pico, and we've got the keyboard in the same layout as the original machine, but this isn't a touch keyboard, this is just tactile switches, and instead of the television we've got an OLED display there. So I'll just turn that on and it'll start up. I've got over here, instead of a cassette recorder, I've got an SD card slot, and there isn't an SD card in there at the moment, so it's saying it's not okay. But it signs on and says experimental schools computer there, which the original didn't do. But if I press that button, you do a normal reset, and this is the display that you get. So what I'll do is I'll go through a simple instruction. Now, so this machine had two instruction sets. There's a low-level instruction set, if you like, which is very similar to the later microprocessor instruction sets that arrived, Z80, 6502, that sort of thing, with a few differences. And then there's another instruction set, and that instruction set is what they called extracodes, and that was a concept which came from some of the older computers like Atlas, where you could essentially jump off to a subroutine, but it's called by executing an instruction. So it's not a jump to subroutine instruction and you give the address of the instruction code. It's actually a mechanism built into the hardware where you can execute some opcodes and they will cause a jump to some code which will perform whatever you want to do and come back again. And on this machine, those opcodes were set up to do floating point arithmetic, because the fundamental data type of the machine in core store is actually floating point numbers. And the machine stores instructions and floating point numbers in core store, but then when those numbers are brought into the registers of the processor, they're always treated as integers. So it's a bit of a strange machine, really, but it was designed to be used at the floating point level, and that is what I'll do here, because they're sort of easier to see what's going on. So this number here is instruction address register, and we're not going to use that because there's a feature here where you can actually execute one instruction from the keyboard without putting it into core store. You just execute it sort of immediately, really. It's an immediate addressing mode for instructions. So if I set up, let's set up location 11, and I will then load that into an address register. So this is just a pointer into the core store. So you can see that 11's appeared here, and I'm going to type a number in. I'll put 123, and then we'll store that in that location. So we now have 1, 2, 3 and 11. I can then move to the next location just by incrementing that address register, address pointer, and let's put some other number, 789, and store that in that location. So now I've got 1, 2, 3 and 11 and 7, 8, 9 and 12. So what I'm going to do is I'm going to do a keyboard input reset. I'm going to do a 70, so that's the opcode for an add, and I'm going to say I want to put the result in location 10, and I want to take one of the operands from 11 and another one from 12. So that's saying add, and then it's a sort of 10 equals 11 plus 12. Then what you can do is you can execute the first step of that instruction. So this is single stepping through the phases of an instruction, if you like, rather than single stepping through instructions and a program. You've actually got the ability to single step the 3 phases of execution of instructions. The first one just works out where the values are going to come from and go to, and then it gets the current values, so you can see these are the current values, and then it performs the operation. So it's added those two together and got, what is it, 912, and you can see that that's actually in floating point, well, plus 912.00. Yeah, so that is the sort of level at which people were programming this, and it was used for mathematical sort of investigations and things like that. So it's very much a mathematical machine. There's no text capability with this machine. It can't handle text. The other instructions and so on are, I mean, there's a complete set which you can find online. And I sort of wrote this because I was quite interested in the sort of programming of the machine, because it was so different to the machines that came after. So unfortunately there's no ROMs for the original machine, so this is not an emulator, it's a simulator, because that was actually lost when the machines themselves disappeared. There is one machine in a museum, but it turns out that that machine is actually just a case. There's nothing in it at all. It appears to be some sort of dummy machine, because the keyboard, which is present, there is a keyboard there, but the keyboard doesn't appear to be a real one. That appears to be a dummy as well, so it is a purpose-built dummy machine. So there's no surviving information that I know of. If some appears, that'll be great, but at the moment there's no surviving information about the internals of the machine, which meant that I had to re-implement everything as a simulator here in the Raspberry Pi Pico. The other sort of problem, is it a problem? Well, anyway, one of the other issues I had was that, as well as no surviving hardware, there were no surviving programs that I was aware of. The records of the machine are really just photographs of the machine. That was all I could find, and the instruction set information. There's a patent which details the internal structure, and a few articles here and there which describe parts of the machine, but I couldn't find any programs. But then I actually found a reference to a course that was written for this computer, which I thought would have programs in it, and I was hoping it would have the extracode code as well, so that the floating point extracode instructions, I could just type those instructions in and it would work. So I had a hunt on the internet, and I could only find one reference to that document. It doesn't seem to be, well, it is online now because I found it. So I had to go to Oxford University to get that document and scan it or photograph it, and that is now online. There is a copy of that, and within that there is a set of programs. So some programs do exist and are now on the internet, which weren't before, but unfortunately it didn't have the extracode instructions, which is sort of like a ROM. It's the floating point instructions, which apparently you had to type in if they ever got lost from Core Store. You had to sit there and type it back in. So somewhere there was a listing of that, but it wasn't in this first course on this machine. So I had to re-implement the extracode instructions, which are in the simulator here. So everything works here. You can save and load states on the SD card, but that's not a very complete bit of code at the moment. I've concentrated on sort of getting some hardware running, but it's a very unusual machine. I'm going to put more information on the web, probably in the GitHub, and maybe on my blog as well, because it's a bit detailed to go into in a video. But yeah, I think that machine is the first purpose-built educational computer. It started in 1966, and the project sort of ended in 1970, so pretty early for a personal computer type machine. But I've not managed to find any others that were purpose-built machines. Quite a few courses teaching people about computers were around before that, but they tended to use off-the-shelf mainframes usually. I couldn't find anything that was purpose-built to teach people about computers. In schools this is as well, so you're talking about older school children